Hi there, I'm Dr. Karen Agar, and this video is an intro to object-oriented programming with Java. In this video, we're going to talk about getting our feet wet with object-oriented programming, often abbreviated OOP. In this video, we're going to be looking at what is a class, what is an object. We're going to discuss the differences between these two. Oftentimes, when you're learning to program, a class and an object can be easily mixed up. So we're going to try to clarify that. We're going to look at attributes and methods and how we can use them. Then we're going to take a look into the code behind a Java class and try to understand some of the methods like accessors and mutators. This is an introduction to object-oriented programming, so this video is going to talk more about what a class is, what an object is. We're going to look at the code for a class and inspect it and understand some of the basics, but we're going to focus more on using the class, calling its methods, creating objects of that class, rather than writing the class itself. So first, let's kick off this discussion with classes versus objects. These are two concepts in Java that are related but commonly confused for each other. So whenever we say class, we want to think about a class as a template for something, an outline or a template to describe something. That something can be tangible, like a car or an employee. It could also be something like a player in a video game, or something not so tangible like scanner. That's actually a class that we've probably been using already. And so if a class is a descriptive template for something like a car, then an object is going to be a specific instance of that class. So if I were to describe all cars, they're all going to have certain attributes or certain things in common. They've got miles per gallon, they've got a color. We'll talk more about that in just a moment. But then we have specific instances of cars. I have a blue Honda Accord. You likely have a different instance of a car. We've got fire trucks, we've got all kinds of examples. So an object is a specific instance of a class. So let's look at an example. If we want to describe a car, let's think about some things that all cars probably have in common. The trick here is not to get too specific so that we can describe all cars. It depends on what it is that you're coding for. So depending on your application, your design might vary slightly. Another word for what we'll be describing is called fields. You'll also see them called data members or attributes, but we'll get exposed more to those words later on. And then after we describe all of the things cars should have in common, all of the data we want to store about a car, then we're going to describe all the actions or functionality that cars should be able to do. They should be able to honk their horn, things like this. So here's our first look at what's called a UML diagram. So over on the left, we can see that we've written car up top. So this indicates that this whole box setup is going to describe our car class. Here we want to list the data or the different fields, all the things that cars might have in common. And then down here, all the actions that a car might have in common. So here I have described some of these. We've got all cars would probably have brakes, miles per gallon, steering wheel, model, VIN, color. This is certainly not an exhaustive list. You could go on, and it just depends, again, on what your application is, what kind of data you want to collect. So then we go down to actions. So an action would be something more like speed up or brake or honk the horn, right? So again, I'm just going to list some examples that I thought of. Got accelerate, brake, turn left, and you can go on and on. You'll notice here that I've got minus signs and plus signs. In these diagrams, the minus signs and the plus signs are significant, but we will talk a little bit more about them later. Again, this is just getting our feet wet. So another thing to notice is that after accelerate here, I've put open and close parentheses. We may have seen something like that before in Java, writing next int, writing next line when we were using the scanner class, and that's because we were actually using the scanner class's methods. So other words for what we've described here, all of these attributes you see described in this first box, they're known as attributes. data members or fields. Everything down here, I've been calling them actions because that's a good way to think about them, but their technical name is methods. So what we've drawn here, again, this is a UML diagram. You'll be more exposed to that later. It's just a nice way to kind of lay everything out in a structured design so that we can then take it and code it. This is an example of a class. So this would be defined in Java, public class car, and we're going to focus on the code for that a little bit later. But the important thing is we should know after this video how to interact with the class, how to understand what this means, and then how to use these different methods. You can see over here we've got pictures of all kinds of different cars. Each one of these would be different instances of the car class. They're all going to have brakes and miles per gallon and models and VINs and colors. They can all accelerate, brake, turn left, blink, etc. But these are all separate instances of a car. That makes all of these objects of a car. So again, a class is the template, an object is that specific example of that template. Just to see another example, here we have a UML diagram describing an employee. So this is an outline of what an employee class might look like. I'm going to say all employees are going to have titles, so their position title, salary, name, department, and certainly you could list others. And then let's say that employees can all take similar actions like clock in, get raise, so on and so forth. And then if you think about all the different employees working for a company, they would each be an instance of that specific class. The actual values for their title and their salary and their name would be different. Maybe Joe is a chef and makes $50,000 a year, and then maybe Bill is an accountant and makes $60,000 a year, right? So the actual values in here are different, but again, the data that we're collecting on them is shared. So let's switch to Java now. What I have up on the screen is a simple class, dog.java, and I created that here in Eclipse. I gave it the name dog, and I did not select the checkbox for it to fill in a main method, public static void main string args. So you'll notice it just says public class dog and the set of open and close curly braces. All of our code for creating a class or a template of type dog is going to go in here. So it's really good practice to, before you even talk about what the code looks like, actually write out in a UML diagram or some other way what it is that you're wanting to get down in Java code. So we're going to do this here in the comments. I want to first list all of the attributes or data members that we want to collect about a dog, and then we'll move on to listing the methods or actions that all dogs have. So for now, let's think about all of the data. Maybe you're designing a program for a veterinarian, maybe you're designing a program for an animal shelter. Depending on the application, you might want to collect different information about the dog. We're going to create a real small toy-like dog class just so we can start getting the hang of things. So let's say that all dogs are going to have a name. Let's also say they're going to have a breed. And let's also say that they will have an age. Note that we could collect other things like weight and owner and so on, but we're going to leave it at these three. So now what I'm going to do is I'm going to take these and actually transfer that to the Java code so we can inspect it. Okay, so here you can see that I chose a string to hold the name. That makes sense. Similarly, a string to hold the breed. And then I chose an int or a whole number for age because I don't want to store things like 7.5 years old. Now you will also notice the word private before all of these. We'll talk more about what private means later on, but for now you should start recognizing that anytime I declare a data member, I want to use this word private, and the syntax is that this is written right before the type declaration, so string or int. Now I'm going to move on to the different methods or actions that we want our dogs to have. Again, depends if this is a dog in a video game, you want him to walk and turn left and bark and whatever. So for simplicity, let's just define one method And let's say that all dogs are going to bark. Again, you've seen me in the UML diagrams always end the methods with open and close parentheses, so I'm going to do that here. Now, before I take this and show you the code for what this would look like, let's actually talk a little bit about what we would want this method to do. So the whole reason in designing this is so that I could create multiple instances of dogs. I could have my dog Copper and your dog Duke, right? And then I can say something like Copper.bark, and that's going to make him bark. Now you can see in advanced programming where you're creating video games or an app, something like that, how that would work. But in this example, when we say we want the dog to bark, we don't know how to do those kind of things just yet, so we're going to say we want woof to be printed down here to the console. Now, if I asked you right now to just step away from object-oriented programming and write a statement that prints woof, W-O-O-F, to the console, you could do that A+ in 10 seconds, right? System.out.print or print line, woof. So with that in mind, let's take a look at what the code for the bark method would look like. So here you'll see that I've now written the code to make the bark method work. So anytime anyone calls this method bark, I'm going to print out woof to the screen. Now a couple things to inspect here. First of all, we can name this method whatever we want. Just like variable names, we want these to be nice and descriptive. So bark makes sense. We could also say speak, right? But I'm going to stick with bark. You'll also notice on this line, I've got the words public and void. Public is the opposite of private, and at this point, know that it's typical to declare any of your methods to be public and any of your attributes to be private. Then I've got the word void here. When I hover over it, it says return type of the bark method. So we're going to learn more about return types in just a little bit, but for now, we're just going to inspect that this word is here, the order in which they're in, and then everything between these open and closed curly braces is what we want accomplished when someone says dog1.bark. So what I'd like to do now is to step away from writing the class and really focus more on using the class. So here you can see I've got dog.java inside of this quick start to programming folder. I've got other things that I've been working on here also, but what I'm going to do is create another file, so a new class inside this same folder. I can name this whatever I would like. I'm going to call it tester file. And I am going to select this main method here. So here you can see my tester class. What I'd like to do inside here is I would like to create an object of type dog. Now note that before we wrote this dog class, I could not create something of type dog. That's not a type that exists in Java. However, because they are in the same folder, I've got my tester file and my dog file here, I should be able to access them and see them. So this is actually really similar to creating an object or an instance of the scanner class. If we think back to what that syntax looked like, it looks something like this: scanner, give it a name, equals new scanner, and system.in. This, we've always said, was creating an instance of type scanner, and we gave it some kind of name. We're going to copy this syntax almost exactly, and instead of creating something of type scanner, we're going to put the word dog here. So I'm going to say dog. I can give it a name. I will say dog1 in this case. Again, the name does not matter. Equals new dog. So you can see that everything matches up here. In creating a new dog object, I'm going to just put open and close parentheses. A little bit later on, you'll understand more of why we put system.in in the parentheses here and are choosing to leave these open when we're creating instances of classes in the first few sessions. So what this is this is one single instance of a dog. So think about this as being my dog. I can create a separate instance of the dog. We'll look into that a little bit later. But the important thing here is that now that I have an instance of type dog or a dog object created, I can now use the dog class's methods. Anytime I want to call a method, and remember the only method that we have is this bark method, our syntax is object name dot, we're actually going to put a period, and then method name. If you think about it, we've done that with the scanner class before. We've used the name of our object. I think in my last video it was keyboard. I know some textbooks like to use SCNR, short for scanner, but we do things like whatever my object's name is, .next or .nextInt, right? And so we're using the object name, a dot, and then the method name. From now on, anytime you see open and close parentheses, even if they have something inside of them, I want you to think method. This is a method of a class. Note that we've also seen open and close parentheses when we said system.out.println. That means that println is a method. Coming back to our dog class, I've got my dog object, so following my syntax, I would do object name, dog1, dot, method name, which was called bark. So dog1 dot bark. And this is a successful method call to our bark method. Anytime you see these asterisks up here, it means that the file is not saved. This button saves all, or you can go save them individually. But if you were having trouble where it was not recognizing your bark method, sometimes it's just because you haven't saved the file, so it doesn't see it yet. So let's talk about what this would do. First of all, I can run this file. I can push this green button and compile and run my tester.java file. Now, the reason that I can run this file is because it contains a main method. Only files that contain this main method, public static void main string args, can be executed or run. And we know that when a file is run, it starts flow of control from line 1, 2, 3, 4, and so on, and executes them in sequential left to right order. So what happens here, all of these are comments, so we can ignore them. The first thing that executes when we run tester.java is we're going to create a new instance of the dog class. We get to talk a little bit more about what that means in just a bit, but after we do that, we have the dog1 object created, and so we call the bark method. What this part does is it actually goes into the dog class. I'm going to highlight this so we can see it's looking for a method named bark that has nothing in its parentheses. And it looks through the entire dog file and I found a method named bark that has nothing in its parentheses. So this line of code is executed. I'm going to copy this right here at this point. So this is like having system.out.println woof on this line 14. Let's run it just so that we can see. Run, and you can see that woof was printed out. Now, if I were to do this again, dog1.bark, as you can imagine, it's going to call this method and print woof twice. Now, you might say, Dr. Agar, that it seems like a lot of work just to print the word woof. Methods are actually incredibly useful. This method that we wrote happened to do something very simple, print out woof. But imagine if you were trying to write a method that did something very complicated. Maybe you were averaging numbers. Maybe you were coding some complex algorithm that looks through DNA. Whatever it is that you're coding, you can write it one time, and then in another file, you can just keep pushing that button and doing it over and over again. This eliminates the need to copy and paste code in a bunch of different places. Not copying and pasting code makes things less error prone. You have everything kind of tucked away in one little place. If I decided that dogs no longer said woof, they now said rough, I could change that in one place, and no matter how many different files I have that has dogs barking, it's going to execute those changes in all of them because they're all using the same centralized class. Hopefully you can see that if you were creating a video game or something like that, and you wanted to design, let's say, a car. There could be tons of different cars that one could choose in a video game, but they're all going to have very similar features. And so if you need to update something, you can update it in one centralized location, and then that updates for all of them. So that's one of the benefits of this object-oriented programming. I do want to keep working with this dog example because at this point you may be wondering, what about all of these data members up here? I created an instance of type dog, so does that dog have a name, breed, and age? The short answer is yes. When you create in this line an object of type dog, there is now space in memory where this dog object has a name, breed, and age. However, we have not set values for those. So think about its name being empty. It doesn't have one right now. However, there's space set aside in our computer where we will store it. So let's talk about setting the dog's name. So the next thing what you want to do is set dog1's name. Now typically when we assign values to variables, because that's what we're talking about, assigning a value to the name variable, we do something like name equals, and let's say the dog's name is Snoopy. So in this case, this is not going to work. It's going to say, I don't know what name is. You haven't given it a type. Well, earlier on, before we were talking about object-oriented programming, we could say something like string name equals Snoopy. However, this does not attach Snoopy or this variable to our dog object at all. In fact, this creates a new place in memory where we can store the name Snoopy, and we already have a place made in memory where we want to store the name Snoopy. So what I would like to get is access to this name variable so that I can store Snoopy in it. So going back to the way that we had it before, this is a common mistake. A lot of people think that because I can see the dog class, I should be able to see the name variable. This goes back to this private access modifier that we saw here. If I were to eliminate this word private, leave it blank, or put the word public here, this name variable is now accessible outside of this class. Now first note, this is not good design. However, you may see this used in early object-oriented programming exercises in your textbook. Note that the word private should be here for good design, but let's explore what happens when I leave it out. So over here we see that nothing has changed. Name is still giving me an error. However, I told you it's now accessible. The issue here is we could have multiple dog objects. Let's say Snoopy is just one dog. Maybe we have another called Scooby, and so on. So we need to specify which dog object are we referring to. So just like here we said dog1, our object name .bark, here we're going to say dog1 .name. Now you can see that all the errors went away. What we've said here is that my dog1 object, I want to get access to its variable called name, already declared in that class, and then assign it the value of Snoopy. Now this looks nice and easy. However, we said that this is not good design. It's not good design because if you think about maybe designing a class for a bank account or something that might have sensitive information like a password, we like to keep all of these attributes private so that we can control how and when they are accessed. So you can see if I change this back to private, again, the correct way to code this, I've now caused this error in my tester code. It's saying, if I hover over it, that the field dog.name is not visible. It's private, so we can't see it. It gives you some suggestions, and if we look at the second one of the suggestions is to create a getter and setter for the name variable. So let's actually talk about what they're suggesting here. A getter and a setter. Both of these, getters and setters, are unique methods that you can write in your class or in your template file. Note that there are better names for these. Instead of getters and setters, getters, or something that allows you to get something, is also called an accessor, and setters are also called mutators because they allow you to set or mutate values. So first I want to focus on what we're trying to do here. We're trying to set the value of this variable name, so we're trying to write a setter or a mutator. So the idea is we cannot gain access to this variable in another class. It is private and we can only access it within the dog class, nowhere else. So since we can't get this variable out of the class, what we'd like to do is get this value into the class. So I'm almost trying to take this value and put it inside of this file. Now, the way that we're going to do that is by writing this specialized mutator or setter method. I'm going to write it and then we'll inspect it. Okay, so here I've got my mutator written. Again, note public and void. We'll get back to what void means later. Public means that it is accessible outside of this class. So notice how we were able to use the bark method in the other class. We can also use this set name method in the other class. So I named it set name. This is actually the convention for how you are supposed to write accessors and mutators. You use the word set, all lowercase, and then you capitalize the first letter of your variable you're trying to set. So in this case, it's my name variable, so set name. Again, if I were trying to set breed, it would be set breed with a capital B here. Then notice that I have the open and close parentheses like I did in the other method. However, this time I've got some information inside. So let's talk about what this is and why there's something in this set of parentheses and not in this one. Remember, we're writing this method because we want to get information into, and that's kind of the key point there, into this class. If we want a place to receive outside information, we need to have it passed into us through these parentheses. Let me show you why. When I called this bark method, notice that nothing else in the method other than the name was seen in this file. So the parentheses here are the only way I can get information from this file into this one. To better control what information we can put in, here I'm specifying I only want someone to pass in a string. I don't want a number, I don't want another dog object, I only want a string. And then this letter in here, I could call this whatever I want, passed in variable name. All this is a name for this string object, so it's an identifier. I'm going to switch it back to in. And so what's going to happen is when someone calls this method, if they pass in the value of Snoopy, this is going to act like we're saying string in equals Snoopy. It's going to store the value that they passed in our little string here that we've created with the letter N. Now that we have a string and I named it N and it holds the value Snoopy, I can just assign that value, again this has the value Snoopy if that's what they passed in, to our name variable. So going back to this file, let's modify this so that we are now using our accessor method. So again, remember, methods are called by using the object name, we're already doing that here, a dot, and then the method name. So here was us trying to access the variable. Again, that's private now, we can no longer access it, but we do have a method and it's called setName. The first couple times you program these, I would recommend copying and pasting the method names to prevent errors. So I'm going to paste this here, setName, and then just like we did with bark, we're going to do our open and close parentheses. Now, this is still not the correct syntax. because remember, this is the assignment operator. And so by saying I want to assign the value Snoopy to this is not something of the type string. We can't fit Snoopy in here. However, there is a place where we can fit Snoopy, and it's right here. So I'd like to inspect how this matches up. So over here, Snoopy is a string. I've put this in the parentheses in the setName method, and where the setName method is written and declared, it says it wants us to hand in a string here. Note that it doesn't have to be Snoopy, right? I can pass in Copper, which is my dog's name, and that's gonna copy over the value of Copper here to the string variable named n, and then the value in n, again, Copper now, is going to be assigned to our name variable. Now the reason we're getting some errors is because this file was not saved. Remember the asterisk, so let's save both of these files, and you can see that the errors go away. So now that we've set the name, let's look at how we can get the name. So let's say we wanted to print the name out. I can't say system.out.println name. It doesn't know what the name variable is, and I can't see it. Again, because name's private, I also cannot directly access it with my dog1 object, but I do want to get the name of dog1. I know that we know it's Copper because we just set it up here. However, I'd like to retrieve it from the file. So we looked at how to set or mutate attributes. So now what we're trying to do is to get or access the values of these attributes. So I want to get or access the name variable. I'm going to write the code and then we'll inspect it. Okay, so here is our code for gaining access to the name variable. First of all, it's starting off with public, just like all of our methods have, but the next word is different. The word that comes right after public is called the return type. So I'll type that here, the return type. And what this means is this is the way that we can get values from this file to an outside file like tester. If you think about it, that's what we're trying to do here. We want to, in this file, put a println statement and somehow gain access to the variable that's in this file. Contrast that with what we did here, where we are trying to get information into the file. So just to review, think of what's between the parentheses as information coming into this dog class. And then this word, which is called the return type, as what information is coming out of this file. With our bark method and with our setName method, we didn't need any information passed back to tester.java. Tester.java said I want to set the name to Copper, and that's it. We didn't have to give them anything in return. In this example, I am wanting to get the name from dog.java. Name is of type string. So here I'm telling Java that you can expect to return a string anytime someone says get name. Now again, they're just going to be saying, hey, give me the name. They're not going to be passing information into us, so the parentheses remain blank. And then the work that we do inside here is we return, note that's a keyword in Java, name. If name was Copper, this is going to return the value of Copper. Now let's practice with calling methods. Our method is called getName. So over here, I'm going to use my object name dot method name, again, getName, and we did not specify that something was in the parentheses. So this method call would place the value of Copper right here, and then we can print it or do anything with it that we would typically do with a string. Let's run this, and it does want me to save my files. And you can see up here, we still called the bark method, and then down here, we set the dog's name to Copper, and then printed out that dog's name. We grabbed it from the other file and put it in the print line statement, printing out the word copper here. Note that you could have multiple dog objects. So here I've got dog2. Again, this is another instance of the dog class. And let's say that I want to set dog2's name to Duke. What's going to print out? These are separate instances. So down here we said dog1.getName. That's going to get the name Copper because we set that name for the dog1 object. And of course, if I wanted to print out dog2's name, I could do that similarly. System.out.println dog2.getName. Save it and run it. And you can see that the flow of control is still intact here. If I swapped the order of these two, it would swap the order that Copper and Duke printed. However, I have Copper dog1 printing first and then Duke. I challenge you at this point to think back through these accessor and mutator methods. See if you can follow this template and write an accessor and mutator for the breed variable. Then use your tester file to see if you can set the breed for dog1 and then get it and print it out. This has been a very quick and very packed introduction to object-oriented programming. Again, at this point, I'm more concerned with knowing how to call and use these methods. We will get more into writing the classes later. However, you really need to understand a little bit about what is happening in this code here to be able to really use it in a meaningful way. That's it for now, and I'll see you next time.